Okay, in this next series of videos, we're going to talk about symmetry. So symmetry is a word that we've all heard before, right? So if for example, if you have maybe a triangle or an equilateral triangle like this, we could, basically cut this in half, right? And we can kind of say, well, it wasn't quite in half, but close. So I'm just going to kind of take this and drag it over a little bit and then say, okay, well, this triangle is the same as it is on the left as it is on the right. Okay, so we say, all right, that's symmetrical. All right, well, that's kind of what we're going to be dealing with today, but there's a couple different types of symmetry that we're going to discuss. One called line symmetry and the other called rotational symmetry. And so let's look at some of the prerequisite skills here. And so the first one asks us to identify each transformation or what type of transformation that might be. This first one looks like it might be a rotation. Okay, it looks like it's actually turning about a fixed point, so we would call this one a rotation. Again, we could say again it appears to be or appears to turn. Okay, remember that ideally these are congruent figures, and I think the image just kind of gets a little bit lost when I throw it up on this smartboard, but I think we get the picture. Okay. Number two, well, again, what kind of transformation is this? So let's maybe say that we're going from the red, I guess, I don't know, it looks like a moon, okay, to the blue moon. Okay, and so we could say, well, it looks like if we actually reflected it about this line right here, that would kind of produce our image from our pre-image. So we would say that this looks like a reflection. Okay, and we could say, well, it appears to flip across the reflection line. Okay, so again, pretty easy. I think from pre-algebra, most of you guys are really pretty comfortable determining what types of transformation those are. Okay, in the next series, it asks us to rotate triangle ABC with the given vertices by the given angle. Okay, so the first one gives us the vertices, and it says 180-degree rotation. So we have to remember that the rule for a 180-degree rotation is that we're just going to take our original ordered pairs and we're just going to make them the opposite of what they originally were. Okay, so that would mean for A prime, our ordered pair would now be -3, +4. Okay, for B prime, instead of being 5 and 1, we would be now -5 and -1. And then finally for C prime, we would, instead of -4 and 0, we'd now be +4 and 0. Okay, so again, pretty easy. If I asked you guys to do that on the coordinate plane, I'm confident that most of you could. And we'll look now at the final triangle. This time it's a 90-degree rotation. So this is where, when we have our original ordered pairs x and y, our transformation here will be to flip x and y and then make y opposite of what it originally was. Okay, so this is kind of our transformation here for a 90-degree rotation. And so that would make A prime, that would now be 5 and +1. That would make B prime 1 and +7. And that would make C prime be -6, +3. Okay, so again, just looking over some review there. Hopefully that's helpful to get you guys ready for your final. Okay, so today we're going to cover actually a couple sections. We'll first talk about symmetry, and then we're going to talk about dilations a little bit, which we did talk about a little bit earlier this year. Okay, and so again, we're going to describe symmetry in geometric figures. We'll talk about our definition for symmetry, line of symmetry, and rotational symmetry. Okay, and so we say that a figure has symmetry if there is a transformation of the figure such that the image coincides with the pre-image. Right? Remember this word coincides. It's kind of like the word coincidence. Okay, so in other words, if we do a transformation on this, maybe it's a reflection, maybe it's a rotation, and it's a coincidence. Okay, it's the exact same image as we originally had. Okay, and so that's sort of what we're looking for, right? Where the image coincides with the pre-image. Okay, and so the first type of symmetry that we are going to talk about is line symmetry. Okay? They also call this reflection symmetry, but let's just call this line symmetry. Okay? And it has line symmetry if it can be reflected across a line so that the image coincides with the pre-image. So if you look at this heart, for example, okay, we have this line of symmetry that is drawn there in red, that red dotted line. And if you can imagine, if we reflected this figure across that line of symmetry, our image would coincide with our pre-image. Okay, so this figure is said to have line symmetry.